This is the TrueLine laser wheel alignment system that will align vehicles from the smallest passenger car to trucks and RVs with 19.5-inch wheels. The system is accurate, easy to use, and cost-effective. You can expect years of reliable service. We use both the latest laser technology and the principles of alignment that have been used in the industry for decades. Millions of vehicles have been aligned with this type of system. The system operates with ordinary flashlight batteries and is completely portable and does not require a dedicated alignment bay. You can use turntables and slip plates on the floor, wheel stands, pulling racks, pits, and muffler racks. Almost any setup will work. We'll show you each part of the system, starting with the wheel clamps that easily mount on the inside or the outside of rims from 10 to 19.5 inches in diameter. Aluminum feet minimize any damage to expensive rims. There are run-out adjustment knobs and a precision mounting disc on which all of the gauges mount. The wheel clamps are first mounted on the wheels without gauges attached in case the clamp is accidentally dropped. All of the gauges are stored on the calibration bar, which is built like a perfectly square vehicle. This allows the technician to verify calibration in seconds before each alignment. The laser guns are powered by flashlight batteries and have no cables to trip over or battery packs to recharge. They shut off automatically, and you can get hundreds of alignments from a set of ordinary D-cells. The lasers are projected across the front wheels and to the rear gauges. Factory toe is set with precision dials that read in inches, degrees, and millimeters. The rear gauges have precision reflecting mirrors and centering scales. Rear camber can also be read with this scale simultaneously with toe. In addition to the 4 toe gauges, caster, camber, and SAI are measured in the front with this gauge. All of the gauges have shock-resistant outer cases to minimize damage in the event that they are dropped. Now that we've shown you the equipment, we will show you how to do an alignment, first on our Easy Train vehicle simulator and then on a car. Easy Train simulates a 4-wheel vehicle with wheel clamps mounted and compensated for runout. You can see the wheel clamp mounting discs in the front and in the rear. The front steering axis can simulate caster and SAI swings of 20 degrees in and out. There are also toe adjusting tie rods for the front wheels. The steering wheel can be locked in a straight ahead position. In the rear, you can adjust toe on each wheel, and you can simulate a straight axle that is not aligned with the center of the vehicle. Assuming all the wheel clamps have been mounted and run-out adjusted, we will first measure front caster, camber, and SAI. With the brake pedal depressor in place, the technician mounts the gauge on the disc in the straight-ahead direction and reads camber. To read caster, he swings out 20 degrees, levels the gauge, and zeroes the caster scale. Then he swings in 20 degrees, levels the gauge, and reads caster. To read SAI, he swings out 20 degrees, rolls the gauge to zero the SAI scale, and locks the gauge in place. Then he swings in 20 degrees and reads SAI. The procedure is repeated on the other side, and the readings are compared to each other and factory specifications. Adjustments are made if necessary. Since caster and camber adjustments disturb toe, these are made first. Next, we'll show you how to measure toe. First, the technician would select the type of alignment he would make, and the selection is based on the type of vehicle, what the customer wants, and the condition of the vehicle. He would choose between a front centerline alignment where the wheels are aligned in the front to the vehicle centerline, a front thrust line alignment where the wheels are aligned in the front to the rear wheels, or a total four-wheel alignment where all of the wheels are aligned to the vehicle's centerline. First, we'll show you how to do a front centerline alignment. The four-wheel clamps are mounted and run out is adjusted on the two front wheels. You're looking at the simulator from the front, and the rear gauges are mounted. The front gauges are mounted. The technician locks the steering wheel. Sets factory tow, turns on the laser and points to the rear. On the driver's side, he sets factory tow, turns on the laser, points to the rear, and points the cross laser to the reflector on the opposite side. He'll now adjust the cross laser so that it reflects back in the hole, as you can see. After adjusting the cross tow, he reads the numbers on the rear centering scales. On the passenger side, you can see that the laser hits at number 8. On the driver's side, it hits at number 4. Using both front tie rods, the lasers are adjusted halfway between, or to number 6, which is halfway between number 4 and number 8. The passenger side. The driver's side. The technician would check that the cross laser is still on the 0, and then he tightens the tie rods, and that completes a centerline alignment. Next, we'll look at a total four-wheel alignment. For this, all four wheels would have run-out adjusted. You've already seen the first part, where the front wheels are adjusted to the vehicle centerline. A four-wheel alignment is completed with a rear adjustment. Looking at the simulator from the rear, the technician is adjusting the laser to reflect back to the center on the thrust line scales. And that completes a four-wheel alignment. Last, we'll show you a front thrust line alignment where the front wheels are adjusted to the rear wheels. All four wheels would have run-out adjusted, and the rear gauges would be set as 0 tow. The front gauges would be set to factory tow, and the cross laser would be adjusted to 0 if necessary. Next, the technician would read the numbers on the thrust line scales. We're now looking at the simulator from the rear, and you can see the lasers reflected back to the thrust line scales. On the driver's side, the number is 6, and on the passenger side, the number is 2. Using the front tie rods, the technician would adjust both lasers halfway between. Halfway between 6 and 2 is 4. He adjusts the driver's side to 4. And then the passenger side to 4. He verifies the cross laser is still centered, locks the tie rods, and that completes a front thrust line alignment. Now that you've seen an alignment on the simulator, we'll show you the same alignment on a car. The technician starts with a pre-alignment inspection and checks for leaky shock absorbers, loose or damaged suspension parts, tire wear patterns, air pressure, and ride height. Any problems should be corrected before the alignment continues. The technician raises the vehicle and mounts the four-wheel clamps and does run out on 2 or 4 wheels depending on what type of alignment will be done. He checks for looseness in suspension. And runout starts by hanging the wheel clamp on the wheel and mounting the caster camber gauge. He starts by rotating the wheel clamp to the 12 o'clock position and zeroing the caster scale. He rotates to the 6 o'clock position, reads caster, and using the two black knobs adjusts halfway back to zero. Rotates to the 9 o'clock position, zeroes the caster scale. Rotates to the 3 o'clock position, reads caster, and uses the red knob to adjust halfway back to zero. He verifies that runout is completed by rotating the wheel and seeing that the bubble does not move. This is repeated on the opposite wheel and on 4 wheels if necessary. He lowers, jounces in preparation for measuring caster, camber, and SAI. He will measure caster, camber, and SAI by hanging the gauge after installing the brake pedal depressor. He reads camber in the straight ahead position, swings out 20 degrees, and zeroes the caster scale. Swings in 20 degrees and reads caster. To read SAI, he swings out 20 degrees, rolls the gauge, locks to zero, swings in 20 degrees, and reads SAI. Would repeat the procedure on the opposite side, note the readings and compare to each other in factory specifications. Adjustments would be made if necessary, and these would be done before moving to the toe part of the alignment. To measure toe, the technician would lock the steering wheel in the straight ahead position and hang the gauges starting with the rear. He would hang the rear gauge and set factory toe. Hang the gauge and set factory toe. Hang the laser gun, set factory toe, and point to the rear. Hang the gun, set factory toe, point to the rear, and point across. The technician reads the scales and makes adjustments as necessary to complete toe. Finally, we'll show you how to calibrate the system. To avoid comebacks, an alignment system must remain in calibration. With the TrueLine system, the technician can verify calibration in seconds before each use. He verifies that the laser beams are centered, he compares the camber scale to the master level, and he checks to see that the camber scales are opposite each other, and that completes the calibration.